In theory also you are having transients.
Ma'am, I have a few doubts regarding the assignment.
Don't call it assignment, that is experiment. Okay. What experiment? Transient only, no what? What is your doubt?
Ma'am, in that E-lab thing, we are getting very short graphs, so it looks like continuous only.
Short graph means you are telling that you are not able to zoom in.
Ma'am, do we have to plot our graph or
No need to plot. The circuit along with the two waveforms, one for input and
we
one
have
for
to
output
copy
that is
that
running underneath,
graph
you print screen and copy. That's all. That is enough.
from there?
Yes, circuit along with the graphs you copy. The graphs are running underneath the circuit, no? Okay, anyways,
Ma'am, do
let's
we have
start
to
the
plot
class.
our
Okay, let's not waste time.
ma'am, ma'am,
So
do
I
we
am
have to
telling
plot the
it's
graph
not
or
necessary to plot the when I am talking, why you are talking along with me, then what will you understand, Samuel? You need not plot the graph. Okay. Yes, I will share. Okay. Yashwant, I will share. Okay, you need not plot the graph sheet. Okay. You are getting whatever waveforms for input and output, one for RL circuit and one for RC, along with the circuit with the waveforms running underneath. You print screen, copy and paste. That's all. Okay.
Ma'am, there is a problem in that.
What problem?
Ma'am, the graph is not coming correct. It's showing like it's just a colored beam.
Then send me a screenshot. Let me check it out.
Actually, ma'am, the
Okay.
net is not working in my area. I'm using broadband and mobile, so I can't take screenshot.
Okay.
Could you
Later on,
please,
whenever it is getting connect.
ma'am,
Later
could you
on,
please
whenever it
use
is
the
getting
circuit
connect.
I have shared? Excuse me, ma'am.
What a
Ma'am,
time anyone should talk. If you are talking, I am talking, then I don't understand you, you don't
yes,
understand me.
ma'am. Yes,
Okay?
ma'am. Ma'am, may I say?
Yeah, yeah, tell now.
Yes, ma'am. Ma'am, I am saying that in the WhatsApp I have shared my circuit. Could you please use that circuit and see for once?
Not now. Okay, I'll finish my class. Whenever I am having free time, that time I will check. Okay?
Okay, ma'am. Thank you, ma'am.
Okay, now people will start the class. Okay, we have already conducted lab experiment that is about RL and RC transients and how the waveform is uh, coming into existence. You need to know. Okay, why it is called as transients. You need to know what is the way of defining the term transients. You need to know what will happen if it is an RL circuit, and RC circuit. You should know. Okay, so first let me define the term transients. Okay, suppose if you are having a circuit where you are having one source. Okay, okay, if you are having a source. Okay, let the source be a step input. All right, and you are connecting via a switch some components, that is passive components. Okay, it may be RL or it may be RC, whichever may be the components. All right, this is a switch that can be opened and closed, and this is the input that you are having, which is a step input. Okay, which is a step input. Step input means it will be at one point it will be 0. At t is equal to 0, it is jumping from 0 to a higher level. That means from low value to high value, it is jumping at 0 instant. Okay, that is the meaning of the step input. So step input as such is not available. So you are replacing the step input by means of a square waveform. What input did you give in your lab for these circuits? For RL and RC that you have tried in each circuit, what was the nature of the input that you have given? When in lab, I told you, no, pick one source. What type of source did you use for RL and RC? RS
Ma'am, square wave generator.
square wave. Okay. So square wave you gave. Okay. That
Yes, ma'am.
square wave is like this. Okay. So it's jumping from low value to high value. high value to low value, it is jumping all of a sudden. Okay, at this instant, if you see, it is jumping from low to high. Okay, at this instant, if you see, it's jumping from high to low. So that can be used to simulate a step input. Okay, that's why you are giving a square wave input. So when this low to high transition or high to low transition happens in the source side, okay, then what will happen to the output? Output will always remain constant or it will make a change. Output in the sense you are having voltage and current. Okay. So what will happen to the voltage and current waveforms or response if you call? Usually input you will be calling it as excitation. Output you will be calling it as response. So what will happen to the voltage and current waveforms if some sudden transition happens in the input side from high to low state or low to high state? Will it be always constant or it will undergo some transition to the output side parameter? That is my question. Are you able to hear me or what? I think you are able to hear me. What question I'm asking? What will happen to the output if you are having some sudden change in the source side? This question I am asking you 3 times and still no answer from your side.
And there will be a variation.
Yes, there will be a variation. The output will not be always constant. That will also undergo a transition. Okay, whenever there is a change in the input, accordingly the output waveforms, that is responses of voltage and current, will also undergo transition. So this transition input will lead to the transition in the output. So there is a changeover from one energy state to the other energy state. So it will take some time to settle from the earlier value to the new value. That is called as your transient period, and that phenomena is called as your transient. So this may happen not only because of the change in the input voltage, it may also happen because of the presence of the switch that you are having in the circuit. Suppose if R and LC parameters are suddenly undergoing some changes in their values, then all these things will also lead to some changes in the response. So all these will contribute to circuit transients. So now how will you define circuit transients? Tell me. Suppose if you are having a circuit where you are having an input which is undergoing a sudden change. Okay, for example, step input, if it is undergoing a sudden change, here it is undergoing a sudden change and it is connected to the passive elements R and L via a switch. Okay, so this circuit may undergo transients, okay, because of several reasons. First reason is because of the change in the step input. Input side, if there is a sudden change, or if the switch is closing and opening all of a sudden, then if the values of R and L are changed because of years or aging phenomena, if it is getting changed, so all these three will have a major effect on the output voltage and current. Okay, earlier if for a low state, if it is having a low value of output, now if it is jumping to high state, the output will also transit. Okay, it will not be always constant. So it is jumping from this state to the other state. This time taken to reach the new state from the original state is called as your transient period. Okay, so understood what is the meaning of transient? What is transient? Just refresh the things.
When the sudden change in output, that when the when there is change in input, the output current may be changed. The output current may be changed, and when the change take place, then that term we define as transient.
Not
When
only the input will change, there might be other changes in the nature of switching and in the nature of changes of LNC. Okay, all are able to see the paragraph that I am showing. Again, if
Yes,
you
ma'am.
read to the system, it is telling that excited by a source which abruptly changes in its value. So source side changes will affect the output, plus other things are switching conditions. Okay, the presence of the switch in the circuit may also lead to transient and the changes of LNC. These three may cause The phenomena that is called as what? That
Transient.
is called as transience. Okay. So if all these changes, then what happens to the output voltage and output current? They will be changing over from one energy state to another energy state. So the time required for the change to happen, that time will be called as what time? The time is called as
Transient.
Transient period.
transient period. Okay, transient period, and transients are for short period or it will occur for a long period. Suppose if you say a
Short.
switch is closed or opened, okay, it happens at, for a long time or it happens all of a sudden.
Short.
Short only. So these short temporary changes, they will be leading to transients. Okay. And one more thing you have to learn out. Suppose if you are having only resistance in the circuit, then there will be no transients. Okay. The transients is because of the main components that are energy storers. So what are the energy storage elements that usually a circuit will have?
Capacitor and inductor.
Capacitor and inductor. So if these two elements are present in the circuit, then surely there will be some transients if there are changes in the input or changes in the switching conditions or changes in LNC. Suppose if the circuit is only purely resistive, means these transients will not occur. Okay, understood? So this is how you will be defining transients. Now we will be seeing to what equations you will get. Suppose if the circuit is RL, or what will be the nature of the waveform. Suppose if the circuit is RL and RC that you are going to discuss. For that you need to know something, some basic relationships you need to know. Already I have told in the earlier class what are the voltage current relationships for R, L and C. So tell me what is the voltage current relationship for R and L and C. For R, by Ohm's law, how can you relate V and I?
V is equals to IR.
V is equal to IR. That is voltage current relationship. Suppose if you are using L, then what will be the
Minus I dI
relationship
by
between V
dt.
and I? That will be given by
Minus I
Faraday's
dI
law
by
of
dt.
electromagnetic induction. E will be or V will be equivalent to L into dI by dt. Okay, that is given by what formula? E is equal to d phi by
EMF.
dt.
E is
Okay,
equals to
Faraday's
EMF.
law of electron.
Yeah.
What? Okay, that is
EMF.
given by yes, CMF equation. Next for capacitor, what will be the equation?
Q is
You are
equals to
relating
QV.
Q and VC and C, no? That relationship will give you voltage current relationship for C, that is given by C dV by dt is equal to I. Okay, so this is how you will be relating V and I for R, L, C parameters. Okay, now after that is being done, so you can see some set of circuits that are present here. The first circuit is representing your what? R component. The second one is representing your L component. The third one is representing your C
C.
component. Okay, there are three conditions. You are having these elements in a circuit, you assume. Okay, these are the network elements. And initial conditions. Initial conditions R will be R only, L will be L only, and C will be C only. Suppose you want to draw the equivalent circuit at t is equal to 0 point. Okay. Then R will be always R only. Same circuit representation you are having for R. But what about L and what about C? How can you represent these two? L is being replaced by OC. OC means what?
Out.
Open circuit. So when it comes to representing the equivalent circuit at T is equal to 0, the inductor should be opened. Okay, the inductor should be opened. And when it comes to the capacitor, what are you going to represent? SC means what? OC means open circuit. SC means
Short
Short
circuit.
Short
circuit.
circuit.
short circuit. So this is how you will be representing L component and C component at time t is equal to 0. Okay, L will be opened and C will be shorted. Okay, now this is for t is equal to 0. Suppose if time is finished, okay, time tends to infinity. Okay, time tends to infinity, you assume. So what are the equivalent representations you have to see to? So this is R, first one is R, R does not change. Okay, what about L and C? Earlier it was open at time t is equal to 0. Now it is
Short
SC,
circuit.
short circuited. And what about C?
Open. Open circuit.
Open. So this is for inductor, this is for capacitor. Okay, these three conditions you have to understand. With that only you will draw that circuit, RL circuit. Okay, T is equal to 0 means L will be open and C will be short. Suppose if T is equal to infinity means while drawing the equivalent circuit, you will be shorting the inductor and you will be opening the capacitor. Okay. Now let's go to the RL transient. You have seen the waveforms no in the graph. So what type of waveform have you got in E circuit tool? What type of waveform have you got for RL circuit? Input you gave is square, no?
Yes, ma'am.
Input was square waveform, but what about the output? Output's nature? It was going like this, isn't it? It was rising transient and decaying, rising. Like this only you are getting waveform, no? This is
Yes, ma'am.
output. So one is called as rising transients, the other one is called as decaying transient. Okay, one is called as rising transient and the other one is called as decaying transient. So you need to know how that nature of the waveforms comes into existence for an RL circuit. For RC, it will be called as charging and discharging period. That you must have studied in your lower physics class, isn't it? Charging means rising, discharging means it will be exponentially decreasing. Okay, that is for RC. This is for RL circuit. All right, rising transients and decaying transients. So if you see to this circuit, okay, you can see this is the waveform for what? This is the waveform for. I have circled, you know, what is this parameter indicating? I have circled it in green. Current. Okay, so current is exponentially rising or it will be decaying. Rising phenomena or decaying? It is rising. Okay, it is rising transients. But if you see to ER is exponentially rising or decaying? ER means voltage across the resistor. So it is also voltage across the resistor is also increasing. Okay, this is ER, voltage across the resistor. But if you see to EL, what happens to EL? It is exponentially
Okay.
decaying. Okay, so this will be the nature of the waveforms that you will be getting. Okay, now how that equation is coming into effect, how that exponential increase or decrease happens, that will be explained with the help of equation derivation only. Okay, so let us go to the equation derivation. This is for all for RL. Okay. So this is the RL circuit that you are trying. We are discussing DC transients, not AC. Okay. So one way it will be having an exponential rise in current. Okay. Another case you will be having a decaying transient. So this circuit, first circuit represents a DC source. Okay. Like you are giving a square input. Same way here a DC source is given. And K represents your what? K represents your what?
P.
That is switch. Okay, K represents your switch. And what are the passive elements that you are having in the circuit?
Resistance and inductance.
Resistance and inductance. That's why this circuit is called as RL circuit. Now, if I am going to draw the equivalent at t is equal to 0, okay, if I am going to represent the same in equivalent form at time t is equal to 0, I told you R symbolic representation will not change. But when it comes to L means what will happen? It will be
Open circuit.
open circuit. That is why in place of inductor you are having an open circuit. Okay, if there is a capacitor means you have to show short. Okay, then you are assuming one current and you are going to derive the formula for current, and in that expression you need to have an exponential term. Because of that exponential term only the curve is increasing, rising transient, that you are going to prove. That you will be doing it by writing KVL only. So what is the KVL expression for this RL circuit? For the first circuit, what is the expression? For the first circuit, what is the KVL expression? Sum of voltage drop is equal to sum of voltage rise. So what is the voltage rise component there? What is the voltage input? That is the voltage rise component. So what is the voltage rise? These things you have studied earlier, no? What is the voltage input? If you circle along the current direction, it is going from minus to plus. So you are giving it E sign. This is your voltage rise element. What are the voltage drop elements?
Resistance and inductance.
Resistance
RN.
and
The voltage across resistance and the voltage across inductance. Okay.
inductor.
So how will you write these two? R, ER and
Minus
EL. Just now I told you what is the voltage current relationship. No. So what is the voltage current relationship? E is equal to
minus
no
minus
minus and
I.
all. Minus I am equating to the other side. No. So that minus will get
Okay.
negated.
Yes.
Okay.
Yes.
So
I
R into I, then I of t, let us write. L into di of t divided by dt. Okay. Now into this expression, I am going to take Laplace transform mathematical technique. Have you studied Laplace transform in your lower class, in your 12th
No,
class?
ma'am.
No.
No, ma'am.
No, ma'am.
Okay, no matter what, in simple terms, I will tell you how to take Laplace transform that you will study in your further classes. Suppose if you are having E alone, that is a constant. So how I will take Laplace transform is, suppose if I am taking Laplace transform of E, that will become E of S. Okay. This term T is representing what? T is representing time.
Time.
Okay. That if I am taking Laplace transform, it will be converted to what term now? T is now replaced by what term?
Yes.
Yes. Okay, T is replaced by S. While T is time, this S is called as frequency. Okay, so the Laplace transform technique converts the time domain parameter to S domain parameter. So S is representing a frequency. So if you take Laplace transform for E means it will become E of S. Suppose if you want to take Laplace transform of I of t, then what will happen? Same way. Again, I am reading the equation. What will be the equation? Okay, E of t is equal to R into I of t plus L into di of t. For this equation, I am going to take Laplace transform. So if I take Laplace transform of E of t, it will become E of S parameter, that is equivalent to R is a constant. So let us not do anything with it. But if you are taking L of I of t, then it will become what? T is always converted to what?
S.
S. So this will become I R into I of S plus L is also a constant. Now comes how many times differentiation of I? How many times I is differentiated?
One time.
One time. One time means you will represent S. Okay. S into I of S. Suppose if you are having two time differentiation, d squared. Okay. Then you have to write it as S squared. Okay, and in short form I am writing. These things you will learn in your future classes. The name of the technique is called as Laplace transform. Suppose if you are having three times differentiation, then what will happen? What will be the equivalent term that you will be having?
S cube.
S cubed. Like that you have to write. Okay, this is how you will be taking Laplace transform. So you have taken Laplace transform. All of you understood what is Laplace transform? In short
No,
form I
ma'am.
am telling you. Nova. Okay. So this was the equation that I have got by writing KVL. Okay. E is the input, that is rise element. These are the ER values and EL value, that is drop elements. Okay, to which I am going to take Laplace transform. Okay, Laplace transform if I am taking means the T parameter will be converted to a S parameter, S domain parameter. That's a general thing. Suppose if for this term if I am taking Laplace transform, that is a time domain parameter, it will become E of S. Okay. Suppose if I am taking Laplace transform of I of t, then it will become what?
IFS.
I of s. Okay, like this you have to write. Plus one more thing how to learn. Okay, suppose if you are having one time differentiation for which you are going to take Laplace transform. Okay, all right, Laplace transform if you are taking, then one time differentiation means s will be the term I of s, like this you have to write. Suppose if it is d squared I by dt squared for which you are taking Laplace transform, it is two time differentiation, so you will be writing it as s squared into I of s. Okay, this is the procedure in short. Okay, there is a mathematical explanation for this. For that, you will max teacher is responsible for teaching this. But remember, this is how you will be taking Laplace transform in short way. Okay, so for this equation, I am taking Laplace transform. So what will be the equation that I will be getting? Why all are silent today? No answer. Some mistake they have did. Come on, are you people there or not?
Yes, ma'am.
Yes, ma'am.
Okay. So the reason, tell me what will be the Laplace transform? Here they have given step input. Okay, step input. Step input means usually you will be writing it as 1 by s, I think. Okay, that is the Laplace transform of step input. That is why they have got e by s term. These are things are not necessary for you to understand, but because of the reason that you are giving a step input, usually for a step input you will be writing the Laplace transform as 1 by s. There are so many other inputs also. If this is a ramp waveform for which the input will be 1 by s squared, like that they will write. Okay, so that is how they have included one e by s there. All right. So this is your step input that you are giving. That is why they have included e by s term there. Okay, after taking Laplace transform. So if you are taking Laplace transform r into I, what will be the Laplace transform?
R I of S.
Yes, r into I of s. Okay.
Then in
Now,
Laplace transformation, only with E we have to do 1 by S.
no, step input. Okay, step input means it is having like this. It is having a graphical representation like this, where at time t is equal to 0, the value will be jumping from 0 to some unity you assume.
Yes,
Only
ma'am.
unity amplitude. For this step input, usually Laplace transform representation is 1 by s. Like that
Okay.
they will write.
Okay.
Okay, for that, because of that only they have indicated that 1 by s. If it is another input, say a ramp input will be like this. Okay, so
Yes,
for
ma'am.
that Laplace transform is 1 by s
Yeah,
squared, like
okay.
that it goes on. Okay,
Okay,
but
one.
here you are, okay, here you are using what input? Here the input that you have taken is step. Okay, that's why that 1 by s factor comes into existence. Okay, and as you told me, Laplace transform of r into I is r into I of s. But what about this factor? How many times differentiation you are having for I?
One time.
One time. So how will you represent it equivalent? Just now I
S,
taught you, no?
S
S
and
into
L of S.
I
S.
of s. So r into I of s plus s into L into I of s. In this side you are having e by s. Now between these two, what is the common parameter that you are having? Common parameter that you can take it out of the bracket now. What is the common parameter?
I, ma'am.
IFS.
I of s.
I of
Okay.
S.
That you have taken it out. Okay. Here you have taken it out. I of s. So inside the bracket, what will you have?
R plus LS.
R plus SL. Okay. So I of s from this expression will be E by S into R plus SL. Alright, now you have to take partial fraction expansion. Partial fraction expansion have you studied in max? So you know how to take partial fraction expansion. So how will you take? You will write it as A divided by S plus B divided by R plus SL. Okay, and you will find out A, B constants, isn't it? So find out A and B and tell me what are A and B. It's your work. What are A, B constants? I am taking partial fraction expansion. Okay, for I of S. So tell me what will be the value for A and B. Up to this, everybody understood, huh? What about the rest in class? They are not opening their
Yes,
mouth.
ma'am.
They should. Roshan, Aryan, Ayush, Shunesh, Samyukta, Pijush, Priyam, Rahil,
Yes, ma'am, I have
Rajashri,
to.
Rishi,
Yes,
Latik.
ma'am.
All of you understood, huh? Karthik, Mayank.
Yes, ma'am.
Yes,
Then
ma'am.
you should respond no rather than being silent always. If you have learnt
Yes,
partial
ma'am.
fraction expansion, tell me what are AB constants.
Okay, ma'am.
Are you doing it or what? What are AB constants? I'll rub this a little bit. Okay, AB constants. Now A into S plus LSR R plus SL, okay, plus B into S, that is equivalent to E I will do, okay. Now suppose if I am putting S is equal to 0, then what will be the answer that I will be getting? A into R will be equivalent to E. So A will be equivalent to E divided by R, like that, okay. Alright, this is constant number 1. Same way you have to put S is equal to another value, so that A is nullified and B will be some value. What is B? Yashwan? So A who understood are calculating A who got
Yes,
it to
ma'am.
be E by R. Okay, same way if you are substituting minus R by L for S, okay, then that A term will get nullified and B will be equated to, B will be getting it as what? Once in my what is B? Yes, minus E by R is correct. It's there on the slide. No. Chinmay, Hazarika. Maniganda, tell me what is A and B? What are B and A? You type in and tell me, Chinmay. What about Maniganda? Prabhas, tell me what are A and B? After partial fraction expansion, what are A, B constants? Maniganda and Prabhas. So I won't be able to know what you are doing on the other side if you are not answering to my queries. What are A, B, Prabhas and Maniganda? Are you people doing the derivation part?
Yes, ma'am.
Okay, if you are taking partial fraction expansion, A will be E by R and B will be E minus E by R. That you have to substitute in the original equation. So original equation was I of S is equal to A will be E by R into S plus B is minus E by R. So minus E by R to 1 divided by I think S plus LS. So sorry R plus SL. So in that they have taken one R outside I think so. So that way it becomes S plus R by L. So again from this equation you need to take inverse Laplace transform. I think inverse Laplace transform also must not have been taught to you. So I will tell you how that answer is coming. Okay, this is after substitution of the AB constants. Okay, here they have substituted AB constants. Okay, here they have substituted A, this is A, and this is your B. Okay, they have substituted and they have got this equation. Alright, now the next thing is, this is again in S domain, I have to convert it back to time domain, so I will be taking inverse Laplace transform. So inverse Laplace transform also has some standard formulatic representation. Suppose if you are having 1 by S as the term, then if you are taking inverse Laplace transform, it will be 1. Okay, so you are having 1 by S term here. First term is E by R into 1 by S. So if you are taking inverse Laplace transform, the answer will be 1. Okay, and the next term is 1 divided by S plus A term. Okay, S plus 1 divided by S plus A, if you are taking inverse Laplace transform, means it will be e power minus AT format. Okay, I will write it and explain. So the final equation, if you are saying that is marked by the arrow mark, that is a final equation. After applying KVL, after taking Laplace transform, after applying partial fraction expansion, then now you have to inverse Laplace transform. So inverse Laplace transform of 1 by S will be equivalent to 1. Inverse Laplace transform of 1 by S plus A will be equivalent to e power minus AT. So that is the standard formula I have given. Now tell me what will be the Laplace transform for this equation.
E by R 1 plus e to the power R minus R by L.
So E by R, then tell me 1 minus
1
e
minus
power minus AT. AT is R by L. So minus R by L T. Okay, that is the equation. So are you able to identify the exponential term that is present at the output current? Is there any exponential term or not?
Yes, ma'am.
Yes, ma'am.
Yes. That is why the nature of the curve is rising transient. Okay, you can see for yourself. Alright. So after taking inverse Laplace transform, you have got this equation. Now one more parameter you have to assume. You are considering that T is equal to L by R. Okay, that is your called as time constant. Time constant is actually dependent, or it is deciding how much fast the system is reaching the steady state. Okay, that is why the time constant is significant. Suppose if it is time constant is low, means the system will reach the final value very quick. Suppose if T is very large, then it will take a long time to settle down. Okay, that is why time constant is very important. So T is assumed to be what value now? There is an R by L term, no? So that will be considered, L by R will be considered as T. So what will be the change in the equation that you will be getting? I of T will be now equivalent to E by R into 1 minus E power minus T by capital T. So where capital T is equivalent to what?
L by R.
Capital T is equivalent to L by R. This is called as what constant? This might be asked in your MCQ. So for an RL circuit, what is the formula for time constant?
For
This
RL
formula is
circuit.
important.
Yes,
This is
ma'am.
time constant for what circuit?
RL
What
circuit.
circuit? RL circuit. For RL circuit, it might come for you in future classes also. So remember this concept. Whenever it comes to an RL circuit, the formula for time constant is what?
L by R.
L by R. And what is the expression for I of T? I of T. I of T is equal to E by R into, this might also be asked. See, they won't ask you derivation and all because derivation needs Laplace transform, inverse Laplace transform and all, for which you do not know, have any knowledge. So they won't ask you to derive all these equations. Only the final equations they will be asking you in MCQ. Okay. E by R also you have to indicate. This E by R, they will group it as I. Okay, capital I. Right. This one they will indicate it as capital I. Okay. So that way two equations are very important. I am writing it again. Derivation they will not ask because you do not know what is Laplace and inverse Laplace transform. For your better understanding only I taught you. So what is the final equation for I? I will be equivalent to I into 1 minus e power minus t by t. This equation you have to remember, where I is equal to e by r and t is equal to, what is the value of time constant?
L by R. L by R.
L by R. These equations you remember. Okay. This is I. But what about the voltage? ER and EL you do not know. So for that some extra derivation they have made. Okay, you know what is E by R? We have derived just now, that is 1 minus e power minus t by t, that they have substituted in the formula, so that I is equal to e by r, that r and r will get cancelled. Now finally the voltage across the resistor will be given by what formula?
E1 minus e to the
E
power
into 1 minus e power minus t. So this is the voltage across resistor element. Same way you need to derive what is the voltage across inductor. Okay. For that again, based upon KVL only, originally you have written this equation. Na? You have written this equation initially and then only you have found out what is I. Same way you know what is E, what is ER just now we have determined. So from that EL you can easily find. Okay, that way what is the formula for EL now?
E into e to the power
E power minus t. Okay, so these final relationships alone you remember, that might be asked in your MCQ, and the waveforms alone you remember. Derivation in between they will not ask. Okay, now this derivation part being over, let's move on to the graphical representation. So because of the reason that all the circuit equations are having one exponential term there, if you see to the graphs that you are drawing for I, in that also you are having 1 minus e power minus t by tau into I. So here you are having an exponential term. So because of this particular reason only it is rising transient. Okay, it is a rising transient, and this is the voltage waveform for ER. In ER also you are having one exponential term similar to this fashion, so it is again rising. But for EL it is not 1 minus e power minus t by t, it is simply e power t minus t. That's why it is a decaying transient for EL. Okay. So these decay and rising transients are the resultant of the equations that we have derived just now. One more thing I wanted to tell you, time constant. So definition of time constant. So how they have defined time constant here? Time constant of an RL circuit is given by L by R. So it is defined as how much time the response takes to reach the final value. How much percent is given? There is one
63.2.
percent, na? 63.2. So if you see to the graph, okay, so wherever it takes the time to reach this steady state, this is your final steady state. Okay, it becomes steady. It is rising and then it becomes constant. So that constant state is called a steady state. So the time 63.22%, how much time it takes to reach the percent of the final value, that is called as what constant? That is called as your time constant. Okay, suppose if that value is very large, means what will happen to the system?
will take more time to
It
reach
will
the
take, see here if you are saying means it settles at this particular point itself, it settles. Suppose if t is chosen larger, means what will happen is the graph will take a long time to settle. Long time to settle like that. Okay, this is for t greater than I mean very greater. Suppose if it's less, means what will happen to the graph? means it will reach the steady state earlier. Okay, that is the significance of time constant. So larger time constant means it will take a long time to settle. Smaller time constant means it will take a shorter time to settle. Okay, that's the thing. So this finishes off rise in transients. Same way you need to discuss how the decay in transients. Rise you have seen, but how it is decaying you have to see. Because in the output waveform you are having a rise transient and then decay. Rise and decay, isn't it? You observed this, isn't it? In each circuit. Yes or no?
Yes, ma'am.
So this decay also how it happens
Yes,
we need
ma'am.
to discuss about. So for that another circuit they have given. Again the switching element is there, but earlier the switch was at this point. Now the switch will be like this. Okay. So if it is closing here, now let us eliminate it. Okay, now I am assuming it is closing here at the second point. Okay. So this will not come into effect. So what will be the KVL equation now if you are assuming I? Now the circuit is closed like this only. Okay. This is not present. So there is no voltage rise element. So total voltage input is 0. So it will be equivalent to ER plus L, and which is given by R into I plus L into di by dt. You have to again take Laplace transform here. So Laplace transform if you are taking means it will be becoming I of s into R plus SL, that is equivalent to 0. Okay, same way you will be deriving the equations and you will be um, taking out inverse Laplace transform and you will find out I of current value. Let's see what that value is. Okay. So here they have assumed one transformation here. Okay. Earlier that while writing equation this was 0. Okay. This is at 0 plus time when the switch is closing at 2. Alright. This is the second one. Okay. Earlier it was rising. Alright. Now what happens if it is the switch was close to 1 point already we have derived, no? I will move on to that circuit all again. This circuit we have seen, okay, first state the switch was close to what point? The switch was close to first point or second point?
First.
First. So for this only you got rising transient. Now what you are going to do is second state. Okay, second state is where the switch is close to what point now?
Second.
Second point. So already you will be the circuit is in action. So 0 plus one parameter will be there. Okay, that parameter is this one. Okay, inductor is actually what type of element, what type of passive element? R is energy consumer. Okay, what about inductor?
It stores energy in the.
It stores energy. So earlier state it would have stored some energy. Okay, earlier says it would have stored some energy. That energy is given by this term, extra term. Okay, that happens at I is equal to 0 plus. Okay, that they have included there, and they have found out this I of s relationship. Finally, that relationship is given by this formula. This is for decaying transient. So if you refer to the graph, you can see here earlier it was rising, now it is decaying. Understood? This is all for what type of circuit?
RL circuit.
RL circuit. What are the two things? Rising transients and
Decaying transient.
decaying transient. Okay, so same things you have to discuss for RC circuit also. Again, I am telling you, they won't ask you in between derivation because you have not been taught Laplace transform, inverse Laplace transform. So they will not ask you derivation, but you should remember what is time constant, what are the equations of time constants for RL circuit, RC circuit, then how that graphical representation you have to remember. Then what are the equations for IE, then ER, EL, those things only they will ask. They will not ask you any derivation. Okay. Now this is for RL circuit. where you will be calling it as charging and discharging. Okay, charging period and discharging period. Now again there is a switching element, again there is a step input, again, but instead of inductor here you are having a capacitive element. Alright, since we are using a different passive element, the nature of the circuit will also differ. Again here you have to assume current I and you are going to write KVL expression. So what will be the expression that you will be having?
E is equals to IR.
E is equal to E by S, because again step input,
Yes, ma'am.
R into I plus 1
I.
by C into integral of I dt you will write. Okay. Again you have to take Laplace transform. Okay. So let's discuss the Laplace transform equation. So this is the equation that you got for which you are going to take Laplace transform. So if you are taking it means it will become R into I of S plus here how many times integration you are having?
One time.
One time integration means divided by S you have to put. Okay, one time derivation means S in the numerator. One
Yeah.
time integration means 1 by SC you have to put. So 1 by SC into I of S is equal to E divided by S you will be getting. So in this S, I of S is common parameter, so we will be taking that commonly out. So we will be getting R plus 1 by SC in this side you will be getting E by S. Okay, so again you will be finding out I of S by taking inverse Laplace transform. Alright, so this is how we will be solving that. And finally, if you are doing that, what is the equation that you have got for I of t?
T by R, e to the power minus T by RC.
So now this can also be written as I into e power minus t by t. So where I will be equivalent to what and t will be equivalent to what? This is for
I,
RC. I
T,
will be equivalent to
T by R.
e by r. What about t?
1 by RC. Nee,
Not
RC.
1 by RC, RC. So what is the time constant for RC circuit? What is the time constant for RC circuit? T is called as time constant.
Yes,
So
ma'am.
what is the time constant for RC circuit? RL circuit, what is the time constant?
L by R.
L by R.
L by R. Okay, so same way, what is the time constant for RC circuit?
R into C.
R into C.
R into C. This is for charging. Okay, where you have determined I. This formula is important, as I am telling you again. This formula is very very important. Okay, and again the other formulas VR and DL you have to know. So let's take it out. The same way, you know KCL equation, you know what is E, you know what is. Now you need to determine ER plus EC only. So EC here they have determined EC is found to be equivalent to what value? E into 1 minus e power minus t by lambda. Lambda is again time constant only, RC parameter. Both are one and the same. Okay. So this is for EC. Same way you will be deriving it for ER also. Again, if you refer to the waveforms here, ER is exponentially decaying. Earlier case it was rising, now it is decaying. And now for capacitor this is rising. Okay, that's why always capacitor it will be charging and discharging, charging and discharging, charging and discharging like that. Okay, rising period will be called as charging and discharging decaying transient. Okay, so this waveform you have to remember the equations for ER and EC. Now discharging what happens? Okay, again I told you. So first state the switch will be connected to what point?
First one.
First point.
One
Wait.
point. Already we have derived equations for that. We have found out what is I, what is ER, EC we have found out. Second state is where the switch is closed at what point?
Second one.
Second point. Now you will be not having this, but still there is a capacitor which would have already charged. Okay. So whatever charge that it has stored, now it will be discharging during the second state. Okay, for that also you have to write KVL. Okay, then you need to include that in the equations. I think only this much I can load in live board. Okay, wait, let me load the pages again. So this is all about RLRC transients. The things that you have to study from this concept is what? Final summary.
Transient.
Time constant.
Time constant for RL is what and for RC it is what?
L by R for RL and RC is for RC.
RC.
Now the diagram I have not loaded anyways. Okay. That is enough for you, I think so. But remember the final equation for I of t. Okay, that is important. Okay. I of t formula you have to remember plus ER, EL, that waveforms how it graphically is represented, that you have to remember, plus what is time constant formula you have to remember. That's all. What is transience you have to remember. So what is transient? Transience. What are transients?
It is a time period in output voltage when it varies from high to
As
low.
you can see for yourself, if it is an RL or RC circuit, there are two states. When the switch is close to first state, when the switch is close to second states, two different states. Accordingly, the waveform, as you can observe, one state it is rising and the other one it is decaying. Okay, one state is charging and the other one it is discharging. So there is a change in the energy state. So the time taken for the output to reach and settle to the second state from the original state is called as transient period. And these transients are coming into effect because of sudden change in input or switching condition or one more parameter.
Input R
Yes,
or
input
L.
change or LC parameters, if they are undergoing some change, that will be leading to transient behavior. And this transience is short lived or not short lived?
Short lived.
Short lived only. Okay, suppose if you assume the lightning that strikes, that is also called as what phenomena? That also happens in split seconds. Okay, so that will also be called as a transient sometimes. Okay, lightning phenomena. Right. And sudden switching. Circuit breaker, have you heard of such circuit breaker and all?
No, ma'am.
No. In your house there will be circuit breaker, switches, all those things. If they are suddenly opening and closing, that may also lead in sudden transient, change in state. Okay. So how the output copes up with that change in state, that matters. Okay. Time constant we have seen, not fuse. A fuse is protecting circuit that will be always connected next to the supply line. Okay. It will indicate, suppose if there is overload or overcurrent, means the fuse will blow.
A short
Okay, that is a
circuit.
protection circuit. Protection circuit, but circuit breaker and all, suppose if you want to connect one relay, okay, relay and circuit breaker, they will be working in coordination. Those things are present in power system. In your homes also, you will be having one small switch, which will be put on and off. That is called a circuit breaker only. In MCB, it would have been written. It's like a switch.
We can say
You haven't seen
is
what,
also
no?
normal switches circuit breaker.
Not normal switch, it's a special switch, a circuit breaker. It will be present in that distribution box.
Okay,
Okay.
MCB, ma'am. MCB.
MCB, yes, MCB. That is a mini circuit breaker. Similarly, you are having a mega size circuit breaker role in power system also. Okay. So suppose if you want to break the components or make the components, they will be using a combination of circuit breaker and relay. Okay. Suppose if you want to connect suddenly anything, then you will make the circuit. Suppose if you want to disconnect anything, you will break the circuit like that. Okay.
Okay.
Alright, so with this we will wind up the class. Only one more topic is left out. How to convert star to delta and delta to star. That we will discuss in the next class plus some short problem. In last class what did we discuss? Three-phase circuits, what are the two ways in which you can give connection?
Star delta.
Star delta. So how to convert that star to delta and delta to star? One standard formula is there. Formula derivation again they will not ask, but the final formula you have to remember, based upon which some small problems they will ask. So with that this unit will be over. Okay, now all have understood RLRC transients, huh?
Yes, ma'am.
I should hear yes from all of you.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, with this we'll wind up
Yes,
the class.
ma'am.
Again, I'm telling you, in between derivation they will not ask because you people don't know what is Laplace, what is inverse Laplace and all. You don't know, so it's a big topic. That's why I try to teach you in a short way. This in derivation and all they will not ask. So final equations, graphical representations, and time constant only they will ask. Okay.
Okay, ma'am.
Okay. So don't concentrate more on this topic. All right. All right. So we'll wind up the
Ma'am,
class.
please
All can.
share this video.
Yes, all videos, class videos we are
Please
supposed to
share this
share.
video.
Yes, yes, I will do. Okay.
Okay, ma'am.
Alright.
Thank you, ma'am.
See, and remember, I think CT1 is coming around November 11. So, all of you submit 3 experiments. Okay. It is not assignment. Experiment, lab experiment number 1, 2, 3, all are over. So, submit those, okay, before deadline. Alright, because now all must
And we
be
will get the
knowing.
proper timetable.
What, ma? Rishi?
Proper timetable.
What proper timetable? Class timetable or
For
exam
the
timetable?
CT. CT,
What
CT.
no? CT, it's not at November, no. The week before they will give you.
1 week before. Okay.
Yes. Alright.
And the what is the duration of paper? 1 hour or 2 hours?
CT1 it will be duration of 1 hour only.
Okay.
CT2 and all 2 hour. CT3 2 hour they will conduct. Okay. I heard from a coordinator it will be
Ma'am, totally how many CTs will be there, ma'am?
3 CTs will be there.
For one
After the
semester.
3 CTs, final semester exam.
Final semester exam plus one lab exam will be there.
Ma'am, when is
Okay, ma'am.
CT1, ma'am?
CT1 November 11 they have
11.
scheduled, I think so. Main exam is on March, around March only, I think so. I think by this time almost got your academic calendar. See, before CT, all should submit all the 3 experiments because I have to take the average and I have to post the marks along with your CT1 marks. Okay.
Okay, ma'am.
So I am not I'm being liberal with you. Those who are joined newly, they are new. So I am giving extra time for them to submit. But here afterwards, I won't extend the deadline. Okay, you should submit within deadline. Okay. Now all are good with the e-circuit. I'm hoping
Yes,
you
Yes,
people
ma'am.
are not having any problem. Okay, so here
Yes, sir.
afterwards you should submit within the deadline. Okay.
Okay, ma'am.
All right, now we can discuss. I'm
Thank you,
closing
ma'am.
the
Thank you,
meet.
Thank
ma'am.
you, ma'am.
Okay.
thank you,
Thank
Thank
you,
you,
ma'am.
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 Okay.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Okay.
ma'am.
Okay. Okay, ma.
Thank you, ma'am.
Okay, ma.
Thank you, ma'am.
Okay.